Good morning. We continue the next part of the lesson. So this is another branch of mathematics, very active branch of research. And the good point is that, as I told you before, the prerequisites is more or less nothing. It's just about numbers. That's called number theory. Today we want to talk about divisibility, and if we can get a little bit of time, just review and recap a little bit about prime numbers. Okay, so in number theory, the main focus is on the set of integers and the famous subset of it, which is the set of natural numbers. It doesn't mean that if you just study number theory books, you will not see any track of real numbers, square root of 2 and that. Yeah, you can find that, but the main focus of a study is to understand the properties of integers. Okay, so here we uh, consider the set Z, the set of integers. So this is the set consisting of whole numbers, positive or negative or zero, okay? So let us say minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. Okay? And then from here we say natural numbers. Let us consider the European school. In American school, n starts from 1. In a European one, probably we start from 0, 1, 2, 3, 4, etc. And then in the book, you see this symbol that they put a positive top on that. This is called the set of positive integers. So what is the difference between z plus and n? So if you stick to European school, n starts from 0, but when you say z plus, it starts from 1. Okay? So this means 1, 2, 3, 4, etc. I saw this notation is in your book, so this is why I'm introducing. Anyway, so in number theory, we want to understand the properties of these numbers, whole numbers, a little bit better. Okay? Of course, this is not a very advanced course in number theory, but that is the idea. So the first thing that we want to talk about today is divisibility. So when we say two numbers are divisible, so of course this is a very simple notion for you. You know that 20 is divisible by 5, but 20 is not divisible by 6. 20 is divisible by 5 because if you divide what you get is 4. 4 is an integer. But 20 is not divisible by 6 because if you divide, you get a non-integer number. Okay, but I don't want to define it based on the division operation. We want to define it based on multiplication operation. Okay, so that is what I want. There is a little bit difference, but not that much. So the first thing, and I want to respect this course, that we have to have a strict definition if we want to start. So definition, this is the definition of divisibility, yes? I want you still have the same idea in mind, but the rigorous definition of divisibility is this. Okay, so I prefer to write them down because that would be a practice of also writing mathematics, yes? So let A and B be integers. Yes? We say that B is divisible. You see, I am defining this term. In principle, it should be written in bold or italics if I am typing it, because that's exactly the concept that I'm defining. We say that B is divisible by A and write. The symbol we use is a little bit strange. This is the symbol we use. You see, when I'm reading it in English, I bring B first. B is divisible by A. But if I want to write it as symbols, this is the symbol which is used. So B is divisible by A. So I write A on the left, a vertical line, and then B on the right. So this is red. B is divisible by A, and write this. If there exists an integer, and I emphasize on the word integer, an integer Q such that the number on the right is equal to the number on the left multiplied by that Q. Yes? That is the definition of divisibility of two integers. And as far as you realize, might be you realize that in English, in mathematics, we read from left to right. If I want to read it, I read it from right to left. It's a little bit awkward. So this is why mathematicians use another word. Okay, A divisible by B. No, sorry, B is divisible by A can also be read as A divides B. This is the one that I would prefer to use. A divides B. So if you want to read this symbol, you can say B is divisible by A. If you want to read it from right to left, if you want to read it from left to right, you say A divides B. Those are the same thing. Okay, so let me give you an example immediately. So number one. So I say that 15 is divisible by 5 since 15 is equal to 5 times 3, and do you know what I would write next? 3 is an integer. And 3 is an integer. Integer. Okay, so if I say, of course, you say that, okay, 15 divided by 5 is a whole number. So, but if you want to follow the definition, as I told you, you have to write it in that way. So if I ask you why 15 is divisible by 5, you need to tell me because I can find an integer 3 so that when it is multiplied by 5, it gives me 15. But if I want to write this 15 is divisible by 5 in the notation that I introduced, how do I write? I write from left to right. So I will say 5 divides 15. Yes? That's the meaning of 5 divides 15. Okay, so for example, I can say that number 2, I can say that a 3 does not divide. If I want to say does not divide, I put this on top. Does not divide 20. Why 3 does not divide 20? Of course, you say that 20 divided by 3 is 6 point something, but that's not acceptable here because you have to follow the exact definition. So why 3 is not divisible by 20? Yes?
Because there isn't an integer that you can multiply with 3 to get 20.
Yes. In other words, so it's because since the only number that when multiplied by 3 and gives 20 is 20 over 3, which is not an integer. Okay? So do you agree if I ask you, if you want, so you see, if I want to make this right, 20 on the left, 3 on the right, and I ask you, can you give me a number so that when being multiplied by 3 gives me 20, there is only one number that satisfies this equality, and that number is 20 over 3, which turns out not to be an integer. So that is the reason that 3 does not divide by 20. So 3 does not divide 20. Okay, let me give you another question. So I don't want to write them down, but I want to talk them orally. Okay, so what do you think about this? 0 divides 5. Do you think that's correct? And then 5 divides 0. So let me write true or false, okay? So next example. True or false? So number 1, let me start with this one. 5 divides 0. Number 2, 0 divides 5. Number 3, 5 divides 5. Number 4, 0 divides 0. Okay. So still, I mean, as you know, there are differences. When you want to write something properly, you have to respect the definition. But if you want to do something in a scratch word, you really don't need to respect these things that much, okay? So for example, if I want to see if 15 is divisible by 5, I don't write something like that in my head. In a scratch word, I divide 15 by 5, it becomes 3, and 3 is an integer, so that's done. And then I would say that 3 does not divide 20. Why? Because I divide 20 by 3, it becomes 6 point something. Then I realize that no, this is not. But if you want to write it properly, this is the way that you have to write it. Okay, now my question for you is that, do you think 5 divides 0? In a scratch paper, what do I write for myself? No, what do I write to answer this question? 5 divides 0. This is the word that you have learned today, but the more usual way that you read it is 0 divisible by 5. Is that right? If I want to answer this question quickly, because it is important to have an intuition about what is going on, writing properly is the next step. To be honest, the first one you have to be creative in. But the mathematics part is not a writing mathematics. I mean, if you can solve a hard problem, you are not good in writing, there will be a professor somewhere to find what you say, and then he will write for you, and then you'll be happy. I mean, the best example is Ramanujan, yes? Have you seen the movie Ramanujan? I don't remember exactly the title, but that is an Indian who actually, it is not very clear how he knew the formulas he discovered. So that's a very nice story and movie if you want to see. And of course, he was not an academic at all, okay? He was just inventing formulas and sending to Oxford University or Cambridge University, and people throw those formulas away, and suddenly realized that person was working on a problem, and then throw this note into the basket, realized that, oh, it seems reasonable, and then take it out, and then invited that person from the very poor part of India to Oxford, and he was generating formulas after the other. But because he was not an academic, he didn't know probably how to write properly. So I mean, that's what I'm saying. The hard part of mathematics is being creative and discover things. But at least this level, you have to be creative and be able to write, okay? Most of the time. So the point is that if you give me 5 divides 0, in my head, I divide 0 by 5. What the answer is? 0 over 5. The answer is 0, and 0 is an integer. So it shouldn't take time for me to say this is true, okay? Because what I do in my head is really doing that. But when I want to write it, I write it a little bit different, okay? So this should be true. But if you want to write it properly, how do you write? If you want to convince yourself that this is the case, you need to ask yourself. You put the number on the right here, and the number on the left here, put equality, and then times q. Then you ask yourself, is it possible for you to find an integer that satisfies this equation? Is it possible? What is your suggestion for q? 0. Is q an integer? Yes. Because I was able to find an integer satisfying this equation, and that integer is 0, then I am done. So I would say this is true. Yes? Okay, now again intuitively. Do you think 0 divides 5 is true?
No.
No, because in your head, what do? You go scratch paper, you write what? You write 5 divided by 0. And then you know that division by 0 is not allowed. Yes? So then probably before even writing it properly, you know that that should be false. But why is that false? Let us discover it again. If this is supposed to work, the right hand number is 5 is equal, the left number is 0, then I ask myself, is it possible that I find an integer so that after being multiplied by 0, the answer becomes 5? Is it possible? No. Because regardless of the number you choose, when you multiply it by 0, it is not possible to become 5. So you will not be able to find such a q, so that is false. Yes? And again, 5 divides 5. In a scratch work, what do? You write 5 divided by 5. What's the answer? Answer is 1. So of course you immediately realize this is true. But if you want to understand it from this perspective, you would say that the number on the right is 5 equals to the number on the left, here is again 5, multiplied by a q. Can I find an integer so that this works? Yes. What is that integer? 1. So this is again true. Okay, but what about the last one? 0 divides 0. So this, if you want to do it intuitively, you go to scratch work, write 0 over 0, and then say that probably it's not allowed or something like that, then you would say no. But that's what I'm saying. In this definition, that is true. So it depends which definition you use, okay? So why that is true? Because you need to do the same thing. You write the number on the right here, equals to the number on the left here, okay, multiplied by a q. Then you ask yourself, is it possible for me to find an integer so that when multiplied by 0 gives me 0? Is the answer is yes?
Yeah.
And here, by the way, you have how many of them? Infinitely many. Because regardless of the value of the integer q, you choose this equality holds. Okay, so because I just want you to be sure that you understand what is going on. If you accept this as the definition of divisibility, still 5 divided by 0 is not allowed, but 0 divides 0 is a true statement. So it depends to the definition that I'm using. Okay, is that clear? Okay. So let us try to understand this symbol better. So let me write something. So there are some other ways to write. So let me write all of them here for you. So one way is to say B is divisible by A. Yes? Another way we just learned today, how do you read it? You read A divides B. Yes? This is the usual, I usually read it in that way, from left to right. But another way of reading is that we say A is a divisor, or sometimes we call a factor of B. Again, from left to right. And then there is another way I can say B is a multiple of A. All these ways of reading are equivalent. But the most common one in number theory is this. But I want you to understand the other ones as well. So for example, here I can say 5 divides 15. 5 is a factor of 15. 15 is a multiple of 5. This is reasonable, yes? Okay, so let me ask you some questions now. let me write example true or false again. True or false. Okay, so let me number one. I'm using these symbols because I already talked about them. So I will write for all A, B, and C in Z plus. A divides B, C, then if A divides B, C, then A divides B, or, this symbol means or, A divides C. This is one statement. First of all, I want you to be able to, when you see this symbol, you shouldn't freak out. It is easy for you now. Yes, this tells you that for every numbers A, B, and C chosen from Z plus, if A divides B, C, then A divides B or A divides C. This is a statement. I want to see if this is true or false. I will write another one here for you. For all A, B, C in Z plus, okay, I want to say that if A divides B plus C, then A divides B or A divides C. Okay, so what is your opinion about if these statements are? So let us discuss about the first. So do you remember, this is either you feel this is true, but because this is universal quantifier, if you feel what is this claiming is true, you have to bring an argument, okay? You have to have a proof for that. But if you believe somehow this is not in general true, then you have to bring an example that shows it doesn't work. It is called a counterexample. Yes? So which one do you think? Do you think this is true? Then you have to prove it. If this is false, then I have to wait for you to bring me a counterexample. Yes? The first one is true. Okay, so if you say true, the hard work is to prove it. But what do you want to say?
I believe it's false.
You want to say it's false. Then you have to bring a counterexample. By the way, bringing a counterexample usually is simpler, but not always, yes? Okay, so do you have your counterexample?
Yeah.
So what are those numbers?
If A is 3 and B is 3 and C is 2, then it shouldn't work.
No, okay, let me, so what you said, it is good to understand these things. So you said A2,
Yeah.
B,
3,
3, C,
2.
2. This is not a correct example. Why is that? Because I want everyone to understand. So he's claiming that this is not true. So what does it mean? It means that he can come up with three numbers, A and B and C, so that what happens? So that this one is respected, but none of them is respected. Is that clear? Because you see that this is not claiming that A divides B or A divides C for every number. This tells you that for every number, if there is a big if this is true, I guarantee one of them. Okay? Is that clear? This is the way that you need to understand these sentences. So this tells you that for every triple of A, B, and C in Z plus, if you respect this condition, then I guarantee for you that at least one of them is working. You want to say no, so it means that you need to bring three numbers for me so that those three numbers respect this condition but does not respect any of them, because this says or. For you, what you have done, the numbers that you introduced respect the first condition. Yes or no? A is 2 divides B is 3 times 2. Everyone, do you think this statement is true or false?
True.
This is 3 times 2, 6. 6 is divisible by 2, so that is really true. So the numbers that you provide, that's good. Good, because you are respecting this one. Okay, But this claims that as soon as this is satisfied, at least one of them are satisfied. So what happens? A divides B means 2, 3 is false, because that's not correct, but A divides C, 2 divides 2 is true. So you couldn't disprove it, yes, because your example actually confirms this is true, yes? Everyone understand that? The example you provided confirming this is true. Do you understand it or not? Because this example tells you that as soon as A divides BC, either this one should happen or that one should happen. And you are confirming that because you gave me 3 numbers that this happens and at least one of them is happening. So you didn't disprove it. Actually, you confirmed that the claim is true. But you said that no, it is not true. So this is not a counterexample. Yes? Everyone understand these things that I'm talking about or not? Okay. So this is not a good situation. So we didn't prove it, we didn't disprove it. Yes? Because for proof, example is not enough. For disproof, I need to bring an example that doesn't work, but this works. Okay, now, what is your opinion? Do you want to change your example? Well, I give you another chance, yes.
Is it a problem if I say like the 2 same numbers? Like here,
No, it doesn't matter because this is claiming for every A, B, and C. Okay, but you don't need to. Yeah, it's very simple, by the way. It's not that hard.
So if I say A is 9
Yes.
and B and C are 3.
Yes, that's good. Yes, because now A is 9, B is 3, C is also 3. Okay, now let us see that. Do you think these numbers satisfy this condition? Yes, now 9 is dividing 3 times 3. Is that right or not? 3 times 3 is 9. Is 9 divisible by 9? True. Yes? So, but 9 divides 3, the first state, this one becomes 9 divides 3. Is this true or false? Is 3 divisible by 9? 3 divisible by 9 is false. Of course, the next one is also the same thing, so that is also false. So this, yes. So you were able to bring me 3 numbers so that those 3 numbers respect these conditions, but none of them is satisfied. Yes? So that's a counterexample. And of course, this is very simple, so you don't need to write it like that. For example, can you give me 3 different numbers now? Can you give 3 different numbers that shows that this is not true? Yes?
A is 10, B is 2, and C is
5. Yes. Let us take A. The reason that I am talking a lot about, because I know that this is a new way of thinking in mathematics, I want you to learn that. So if A is 10, B is 2, C is 5, do you think that these 3 numbers that you provide respect this condition? Is that right? Because if I multiply B by C, it becomes 10. Is 10 divisible by 10? Yes. So these numbers respect this condition. But these numbers respect none of them. Yes, because A divides B means 10 divides 2 or 2 divisible by 10, which is nonsense, yes? A divides C means 5 is divisible by 10, which is not correct, yes? So I would say that this is false. So what is this claiming? This is claiming that if the product of 2 numbers is divisible by a number, at least one of them is divisible by that number. We showed that no, this is not correct. So that's why I'm saying I want you to understand, because when I express it in this way, I don't think it is hard. So forget about this. Instead of writing it mathematical symbols, I say you this English sentence. I say that, is it true that if the product of 2 numbers is divisible by a number, at least one of them is divisible by that number? Yes? It is clearly not. Yes? For example, 2 and 3. 2 times 3 is divisible by 6, but neither 2 is divisible by 6 nor 3 is divisible by 6. Yes? So if I express it in that language, might be you understand it better. So in this course, you should be able to read these symbols and interpret it in plain English or in your own language. And then it becomes very clear. So now can you read this one? regardless of this is true or false. Can you read this in English for me? Of course, you can say for all A, B, C, not like that. Just like a conversational English, yes, colloquial English. How do you read it? What is the message of this formula? It is not clear that it's true or false, but forget about it. How do you understand this? What is this claiming? What is this claiming? In colloquial English, not very. So. Yes? Then, or means at least, yes, in language. When you say this one or that one, it means at least one of them, yes? Yeah, that's exactly. So if the sum of two numbers is divisible by another number, then at least one of them is divisible by that number. This is the way that you need to read this mathematical sentence. Okay. Now, if you read it in this way, if you see this and be able to read it the same way that I did, it is easier for you to see if it is true or false. Is it true that if the sum of two numbers is divisible by one number, at least one of them is divisible by that number? It's very clear, isn't it? What is that?
False.
False. So what is the counterexample? The simplest one, yes?
A is equal to 10, B is equal to 7, and C is equal to 3.
No. So you said that A, what? 10?
A is equal to 10, B is equal to 7, and C is equal to 3.
No. Ah, yes, thank you. I was confused myself. So the BNC. Yes, that's correct. That's a counterexample. Why? Because the numbers he provided respect the condition that we read, yes? B plus C is how much? 10. Is 10 divisible by 10? Yes. So we are respecting the first part. But is the second part respected? No, because none of them is true. Is it true that 10 divides 7? In other words, is 7 divisible by 10? No. Is it true that A divides 3? In other words, 3 divisible by 10? No. So it means that this is not the case that if the sum of two numbers is divisible by a number, at least one of them is divisible by that number, and that's a counterexample. Yes? So both of them are false. Okay. Now, let me now write another example here. So number 3. For all A, B, and C in the positive integers, the reason, of course, this is also, we can talk about all Z. The reason that I am talking about Z plus, because I don't want to be worried about that case that one of them is 0 and then you are facing some problem. That's the only reason. What do you think about this? If A divides B and A divides C, can I conclude that A divides B plus C? A little bit different, yes? So now, before doing that, can you write it? Can you read this in plain English? Because this is the important skill I want you to learn, okay? So, and by the way, I told you before about that. When you see this formula, there is a message behind every formula that you have, yes? So, when I see this, this means that if I have a sum of two numbers and I want to square it, then the answer is the square of the first one plus 2 times the first one times the second one plus the square of the second one. So that is the message behind this formula. Yes? What is the message behind this, regardless of if it is true or false? Then we discuss about if this is true or false. How do you read it in plain English? Yes?
If B is divisible by A and C is divisible by A.
No, you are reading it sentence by sentence. The message.
If you can divide B by A?
No, I don't use letters A and B.
Oh.
So here, I didn't read it as A plus B to power 2. I told you that this, if I told you that the square of the sum of two numbers, yes? Do you want to fix it?
Yeah.
Yes?
So if you can divide an integer by a number and another integer by the same number, will you be able to divide the sum of the two integers by the number?
Okay, there's no question here. You're asking a question. This is a statement, so it should be a declarative sentence, yes?
So okay.
But that's correct. But that's not a plain English. You can polish it a little bit. Yes, that's correct. If you write it, that's okay. But how do you polish it? Yes, do you want to say something?
How do you say? If two numbers
This is the good. If two numbers
are
are divisible
divisible
by a single number,
by a single number,
not those. You shouldn't say a number. Yeah. If two numbers are divisible by a number, then
the sum of those numbers should be divisible by the same.
Is divisible by the same number. That is a better way of reading it. Yes. This tells you that if two numbers are divisible by the same number, then the sum of those numbers is also divisible by that number. So now, do you think this is true or false? Now that you understand how to read this sentence, then you can evaluate it. Is it true or false? Of course, the first thing comes to mind is example. Yes? Our brain, from biological point of view, has evolved in a way we cannot see the entirety. Yes, we start from by the way, this is the philosophy of reductionism, yes? So in principle, I just want you to see, if I read this one, for me as well, the first thing that comes to mind is to check some examples to see that what is the direction I have to take, yes? Should I go for a proof or should I go for a disproof? Because if I want to go for a proof, I have to have an argument. If I want to go for a disproof, then I have to have a counterexample. And they are actually completely different paths. Yes? So which one, so what is the example comes to mind? Give me two examples of two numbers which are divisible by the same number. Yes? Yes, let us see. 49 and 7. So and we need three numbers involved. Yes, you don't get confused. Yes, why you're getting confused? How many numbers are involved in this statement that I read for you? Three numbers. So I have to wait to give me three numbers, but you just gave me two numbers. Okay? So what? 49, 21, and 7. Okay. So which direction I have to go? So which one is A, which one is B, which one is C? A is equal to 7. Yes, thank you. Because you are writing it the other way around. So A is 7. B is this number, yes. C is this number, yes. Okay, so this is something good. So in principle, if I ask you, these numbers they are respecting this condition? Yes or no?
Yes.
Yes, because A, which is 7, divides B, which is 21. Yes, that's correct, because 21 is divisible by 7. So yes, you respected that. Okay, the next one. A divides C. Is that also correct? Yes, 49 is divisible by 7. Now, let us add B and C. Yes? So B and C, sorry. Let us add B and C. If you add B and C, what happens? It becomes 70. 70 is divisible by 7? Yes. So this is an example which shows that this is correct. Now, might be you say that, okay, let us find another example and find this. After a while, you have to decide if you want to go for a proof, or might be there is a counterexample that you couldn't find. Okay? So can you say that, is it true or false yourself? What is your feeling about it? It is true. Okay? Yes, it is true now. But it is not clear. So you need to work with some more examples so that you are convinced yourself. It is a subjective matter, yes? So you need to convince yourself. And when you convince yourself that this is true, so let us say that, okay, I am a little bit suspicious now that this is true. And now I have to start proving that, okay? So now, we want to show that this is true. So let me start, and I will start asking you questions. So what I have at my disposal? I know that I have three numbers A, B, and C, so that A divides B, A divides C. Okay? So I would say that let A, B, and C be elements or numbers or whatever you want to say, elements of Z plus, such that A divides B and A divides C. Okay. Okay, then what is the meaning of A divides C? A divides C implies what? Yes? Okay, how many of you agrees with this way of writing? Yes or no? Yes or no?
Yes.
Yes or no?
No, we have to specify the Q.
Q. You cannot just put a letter inside your writing in mathematics without saying that. What is Q then? Oh, but you have to write it. Yes? For some integer Q. Yes, you have to write it because no one knows what Q is. We are talking about this topic right now here. We know what Q is. Okay? So you are not, and then instead of writing that, you either write with words for some integer Q, but we also learn this quantifier. So there exists a Q where in Z such that B is equal to A times Q. Yes? If you prefer to write it like this is read, there exists a Q in Z such that B is equal to A times Q. Okay? Or you can say B is equal to AQ for some integer Q. Okay? Yes?
So can you choose if you want to use a symbol, if you want to write for some integer Q?
Yes? Yeah, it's completely okay. And then of course you can also include it here. So such that, therefore, I would write it the other way around, so this is more beautiful to write. But this is something accepted. Okay, now another scenario. Okay, can anyone else translate this for me? Because I have this one, I concluded something from it. If someone asks you why this is true, what is your answer? What is the simple answer to this question? If someone says why, what is your answer?
Because of the
Yes, this is we say by definition. Okay, what is you are telling is simply by definition. Yes. Okay, so A divides C. Anyone, any other one? Can you translate this for me now? What can I imply from this statement? Anyone else? There is a pitfall in it. I hope that you are not falling into it. Yes.
There exists an integer, let's say n, where
Okay, that's very good. So you didn't fall into that fault because people sometimes usually write this. This is my experience. Okay, they write C is equal to AQ. Okay, but this is not correct because when you say there exists a Q and then use the same letter here, it means that these Qs have to be the same. But there's no guarantee that they are same. They might be the same or not. So then you have to change the letter. Okay, so if you use Q here, you can use another letter here, but usually is that you put a prime or 1 or 2 or something like that. You can differentiate between them. This prime doesn't mean derivative, by the way. Okay, so this I have to write it. So this is important. Okay, now what I want to see, I want to say something about the sum. So therefore, so in principle, this should be comma, this should be full stop, and then I would say therefore. So what should I write? Therefore, what happens? I want to say something about B plus C and its relation with A. It motivates you to do something here. You have B alone, you have C alone, but you want to have B plus C. What is the first natural thing comes to mind? No, please talk to me because I don't really understand if you understand what I'm saying or not. So you have B and A in one relation, you have C and A in one relation, but your goal is to say something about B plus C and A. Okay? So what is the natural thing comes to mind? The next step. What is the natural thing? No, everyone, please. Yeah, come on, yes, everyone.
Add them.
Yeah, it is, isn't it natural? Because I want to have b plus c somewhere. Because I want to say something about b plus c, so I have to have something about b plus c. Therefore, b plus c is equal to aq plus aq prime. Agree or not? Because I know that b is equal to this number, I know that c is equal to this number, I want to say something about b plus c. I start adding the left-hand sides. If I want to keep the equality valid, whatever I did on the left-hand side, I have to do on the right-hand side as well, otherwise I will not be able to keep the equality, logically, yes? Okay, so we have b plus c is equal to. So what can we say now? Therefore, or we can say, therefore this is the case, or b plus c is equal, what do you think I will write next? Yes? Factor a. Yes? Yes. A times q plus q prime. Is this a step natural for you? Because you want to say something about b plus c and a. Okay, so I factor it out. And then I want you to see, am I done or not? Q is what type of number? Is an integer. Q prime is another integer. If I have two integers, if you ask me, Bobak, do you know the values of them? I would say no. I don't know what the value is. What the value is. So I don't know the sum. But I know something. I know where it belongs to. It belongs to, yes, z. Yes. If I have two integers and I add them, it definitely becomes an integer again. Yes. Now look what happened. An integer, whatever it is, I don't know, but I know it is an integer. After being multiplied by a, gives me b plus c. So what does it mean? It means b plus c is an integer multiple of a. So it means b plus c is divisible by a. Yes? Yes or no? So you should say, on the other hand, q plus q prime is an integer. So a divides b plus c, and we are. Yes, is that clear? So this is true. Now I can take this question mark off. Okay, so let me see that if you really understood what is going on. So number 4, for all a, b, and c in z plus, I want to write this. If bc divides a, then b divides a and b divides c. So true or false? But again, let us practice to see if you really learned. Can you read it in plain English? What is the message of this statement, regardless of being true or false? Yes?
If a number is divisible by the product of two other numbers, then the number is divisible by one of the factors.
You start very good, but the last part is not correct. Can anyone complete? Yes?
If there exists a number that is divisible by two different numbers, then that number is either divisible by any of those numbers.
No, first of all, I didn't say might be. This is and.
Oh, and yeah, okay.
Yes? No, or is the other one. Yes? So either you are not allowed to use the English word either. So can you correct it again?
If one number is divisible by two different numbers, then that same number is divisible by
Can you start from again? Begin.
if any number is divisible by two different numbers.
No, if a number is divisible by not two different numbers.
Ah,
This is not two different numbers. BC is
two different numbers.
no B and C are two different numbers. But this is not B and C. This is B times C.
Yeah, multiply by each other.
Okay, but again, if a number is divisible by,
Two different numbers.
but you are saying the same sentence.
Multiplied by each other.
Oh, okay.
Multiplied by
Yes,
each other.
multiplied by each other. Oh, so what is the, instead of saying two numbers multiplied by each other, we have a better English word for it. What is that? The product. But what you said now is correct. Okay? So yes, if a number is divisible by the product of two numbers, then that number
Then that number is divisible by either one of those numbers.
either means or,
Oh yeah,
by both of them.
by both.
Yes, that's correct. So if a number is divisible by the product of two numbers, that number is divisible by each one of them. Yes, or something like that, or yours. But this should have exactly the same message in it. Yes. This means and. This means or. Okay. Now, do you think it's true or false? Again, you have the same intuition. True or false? If it's true, you have to prove it. If it's false, you have to falsify it, disprove it. And then, of course, the first thing comes to mind is playing around a little bit with some examples to have to develop some intuition about it. It is very, I mean, it shouldn't be hard at all. If a number is divisible by the product of two numbers, what happens for each one of them? Yes. So you say, let me say, you have A divided by BC. Yes. If A divided by BC is an integer, do you think A divided by only B is also an integer? Yes or no? Yeah. Do you think A divided by C is also an integer? Yes, because A divided by the product was an integer. So, of course, it should be clear for you that A divided by B only is an integer, A divided by C only is an integer, yes? So, yes. So, in principle, we think that this should be true. But how should I prove it? Okay? Okay, so now, can you complete my sentences? Let us keep them. So, let A, B, and C be elements of Z plus, such that, what do I write here? Yes? Aha, yes. Isn't it A? Oh, okay, so thank you very much. If you, but you need to trust yourself to say something, okay? Is it right? No, this is C divided by A. It's what completely wrong, yes? So this should be C. And then I don't understand how you could read it. So you're actually trying to read my mind rather than what was written on the board, yes? And I don't know how you did that, okay? You could teach me later. Yes. And it was very strange, because that was in my mind, and you were reading my mind rather than what was on the board. Okay, so anyway. So now that is the correct way of writing it, yes? Am I right? Yes. Okay, now can you complete it for me? Now intuition is correct, yes? A, B, and C be elements of Z plus such that. What do you think I will write here? BC divides A. Because I am assuming this is true. Okay? So let me change my style now. Therefore, there exists an integer Q such that, so what do I write here? Can you help me? So you see, last time I used mathematical symbols, but usually this is the way that you see them in articles. Okay, so let A, B, and C be elements of Z plus such that B, C divides A. Therefore, there exists an integer Q such that the right-hand side is equal the left-hand side multiplied by Q. Yes? Okay. Now, how can I conclude that? You need to see that you need to prove two things because they are connected by and. I have to show that B divides A is correct. I have to show that C divides A is also correct. So I have to prove two things. Okay? But the proof is actually very simple. You just need to write it down, okay? So such that this happens. Okay, now A is B, C, Q, okay? Let us concentrate on the first one. B divides A. What do you think I will write here so that I can convince you B divides A is true? Because if you understand what is going on, everyone should be able to write something in front of it. So let me guide you. You want to have this. If it is hard for you, you go to a scratch paper, you ask yourself, I want to prove B divides A. What should I do? What I need to do to prove this? I need to prove that the right-hand side is B times a Q, and then I need to convince myself that Q is an integer. Okay, so if you don't know what to do, you go to a scratch paper, you ask yourself, I want to show that this is true. What I am supposed to do to guarantee this is true? You tell to yourself that, okay, I need to convince myself that there is an integer Q so that when it is multiplied by the left-hand side, it gives me the right-hand side. Okay, so this gymnastics going from the paper to the scratch paper and backwards, this is something that you need to learn. And by the way, it's very simple, okay? Okay, so what should you do? What do you think I will write here now? If you understood this. There is no division. You mean the fraction line? What do you mean by divide? No, we don't have access to the fraction line here. The fraction line is some intuitive idea that we think about it. We have to use the definitions. Okay, you mean this one? Okay, but okay, tell me what I will write here. B.
No. Yeah, BCQ.
What?
BCQ.
BCQ.
The line.
A.
No, wait. Wait.
No, because yeah,
Oh, the opposite.
the opposite.
Yeah. Oh, but then the bracket, like
Where?
BC.
Are you happy?
You should maybe.
No, because no, it seems you are happy, but you shouldn't be happy. Yes. Your character doesn't take life very hard. Yes. So, yeah, that's good, by the way. You could be happy, but I mean, I just told you I don't want to show this. By the way, is this true or false? Is what Nazanin said true or false?
False.
True or false?
False.
Come on. Is this true or false? Could you think before having Math 5 or not? Is it true or false? Yeah, what Nazanin said is true. But I don't want to be offensive, but true, useless true. Yes? Yeah, you said something true, because if these two numbers are equal, of course this one is divisible by that one. Okay, so then what? You don't even need to write all these things. Just even if you don't see this from here, you can jump here, because if two numbers are equal, one of them is divisible by the other. That's good for sure. So that's what I'm saying. You said something true, which is not helpful for the problem that we are working. Okay? So this you need to write something. I told you, first of all, this is important. This going back and forth is not hard. What you want to prove is this statement. You don't see any track of Q there. Okay? So it means somehow you should come up with a logic that enables you to get rid of that Q that you don't need. Yes? Because there is no Q here. You want to say that A is divisible by B. Yes? There is no C involved here. There is no Q involved here. Of course, it was very easy that I dropped this Q and C, but unfortunately this is illegal. We cannot just drop what we don't like. So we have to find a legal way to do it, exactly like lawyers do to escape taxes for the clients, you know. So here in Sweden, you can find a very nice way to escape taxes legally. Yes? So that's exactly what you are doing here. So you need to find a legal way to get rid of those extra things that you don't like. Okay, so what you need to do? Yes? Let us give the opportunity to Jaffer this time, yes. Yeah, you can go on, yes. So what do you think? So this is statement true, useless true. Yes? So we clean it. Okay, then. Can you speak louder, please?
We will also have to find an expression for B divides A.
Okay, when I'm asking you, I don't want your ideas. I want the ideas being polished and say what I have to write here. I don't want you to read your scratch paper to me, okay? I want the final polished idea. What do you think I will write here? A equals BQ.
And A also equals CQ prime.
And A is also CQ prime.
That's it. That's as far as I've gone.
Okay. So I have to actually kill myself. Okay, I don't understand. So by the way, this is very strange because you know that logic should be in your brain before. So how do you conclude from that this one? By the way, so abracadabra, Q prime appears. So what is Q prime? No, I want you to understand this is not we know right now, but you're using it. You are translating this in a very, like if I want to speak Swedish, I will speak like that, okay? I don't know how to speak it. Okay, so that's exactly what I'm saying. This, even if you want to write this, the place of this is here. Yes? Not in your writing. So do you understand that this is completely sorry for that nonsense? Because you say that if you are telling me A is equal to BCQ, I can conclude that A is equal to BQ, okay, but suddenly A is also equal to CQ prime. Based on what you see here, you are concluding these two. But I understand what you mean. What you are writing here is loud thinking or scratch paper word thinking. As exactly I told you here, yes? I told you that if you want to prove this, if it doesn't come to your mind directly, you go to scratch paper, ask yourself this question. My goal is to prove this statement. What can I do to show this statement? Then you write, okay, if I want to show that this A is divisible by B, I need to be able to show that there is an integer so that after being multiplied by B is equal to A. And then suddenly you take it for granted that yes, there is an integer. Do you understand what I mean? You write your desires on the board. Yes? So that's not correct. Okay, I'm just waiting for you. This becomes very interesting for me, by the way. Yes? So what do I write here? Again, let me repeat. Your goal is to prove this. If you are not very skillful right now, you will become skillful if you listen to this. You would ask yourself, to prove this, I need to prove A is B multiplied by an integer. This is your goal. Okay? So, how do you think, what I will write here so that it helps me to achieve my goal? Yes, Sam?
A is equal to B times C cubed.
So let me write. A is equal to, write every detail, tell every detail to me. A is equal to,
B times CQ in parentheses.
okay, first of all, let me ask, is this a valid step to take or not? Do you agree that if this is true, the truth of this is also guaranteed? Yes or no? Because in principle, A is copy-pasted, equality is copy-pasted. This part is not a copy-paste of that one, but because of previous knowledge, you know that there is no difference if I multiply BC first and then by Q, or C by Q first and then by B. So this number and that number are the same, so I can do that. So that is a legal step. Okay? What Nazanin told, that was also a legal step. Yes? But in that case, it was legal, useless legal. But is this useful or not? Okay, so anyone else? I want to tell me why this is useful and finished. Yes, Jan Nazan, yes, you can fix it yourself.
Okay, we'll try. Okay, so you can say that you can when you have like any outside.
Yes?
So you can say that it's divisible by 2.
Okay, why? There is one thing that I want you to refer to it. Why? So yes, you are right. I can conclude that B divides A. You are right, and we are finished. But to take this step, I need to be sure about something. What is that something? Not Q. Not Q. Be careful. No. What? CQ. Yes? Because you want to, this is not hard by the way, because when you want to prove A is divisible by B, you should be able to show that A is an integer multiple of B. Yes? Is it guaranteed that CQ is an integer? Why? Because Q was an integer, C was also an integer from the beginning. So the product of them is an integer, yes? So let me make it shorter a little bit, we don't have that much time. So CQ belongs to Z, therefore I can conclude that B divides A, okay? But this only proves this one, but I have and here. So not only I have to show this to be true, I have to show this one is true as well. So what do you write here now? Yes?
A is equal to C times BQ.
So what you said is equal to what? CBQ. So because what I heard, I write. Assume that I'm a robot. So what you say, I write. Is it finished?
A is equal to C.
Okay. So I would say that, on the other hand, A equals to BCQ implies, now everyone, what do you think I will write here? Help me to live, yes? What should I write here? A is equal to what? C times BQ. Okay, and then can I conclude that C divides A? What should I write on top? BQ belongs to C. Yes? It is very simple, by the way, but the reason that you find it a little bit hard because you don't know how to write it down, okay? It is important to learn how to write it down. Is that okay or not? So, what time is it? We have time, yes? Any questions so far? Yes?
If this was an exam paper, do I have to write hence the statement is true, like under?
It depends. It depends to your subjective way of writing. You know, everyone has its own. You have your own style of writing. Just use it. Okay. Yeah. And of course, if your English is better, you can phrase these sentences even much better than me. Okay, but so for example here, this is common in math text. People write it like that. But if it is a little bit formal, they write everything in words. Okay, it's not that much good. But this is completely okay for the exam. Okay, yeah. Is that clear? Okay. Okay. So do you? Because of my experience is that when I see your faces, one thing comes to your mind immediately, that what happens, what can I do in the exam? Okay, how many of you thinking in that way? None of you? Are you stressed a little bit about the exam of this course?
Yes.
Okay, because, okay, so I can't read it from your faces, okay? But what I'm trying to say is that to be brave. You shouldn't care about grades that much. I understand the problem. Let me close this.